So we're going to do things a little different today for our presentation, and inspired by the coach, we're going to sing our presentation.
Yes.
Okay. Okay. No, not really. But it was a cool idea. So we're going to do something, like I said, a little bit different. I'm going to speak for just a few minutes to kind of get the topics in your head, all right? And then what I want you to do is listen as I bring up two of my friends, and we're going to have a little informal panel discussion where I ask them some questions. We draw on their vast experience answering those questions, and then we open it up at the end for questions. So we want this to be interactive. This is not just us speaking. So please write your questions down as we speak. Ask them when we get to that point. All right. So here's the topics we're going to talk about. So we're going to talk a little bit about just an intro and some key definitions. Why do we have a need for data scientists? And this is really from a business perspective, not technology. Okay? And then what are some of the challenges we've seen with big data and AI? You've heard that in some of the other speeches, but we're going to go over that as well. And then there's one topic that's near and dear to my heart is IoT, Internet of Things, and there's an industrial version called IIoT, and I can talk about that for a little bit. And then we talk about this concept of AI and what are some of the outcomes. Then we're going to have the panel discussion where it gets very interesting, and we're going to open it up for question and answers. So, why is there so much buzz? You hear these terms, and I spelled them out. Most people know what they are, but IoT, Internet of Things, machine learning, artificial intelligence, why is there so much buzz? We're going to talk a little bit about that. For one thing, if you think about it, how many of you have heard of AI for a long time? So I'm a little bit older, just a little bit. And so back when I first started, there was no such thing as big data, at least that it wasn't called big data, and there was nothing called machine learning, right? But there was the big buzz about AI, and there are lots of movies over the years, but you really didn't see AI making its way into the mainstream. So that kind of leads to the question, why not? Why hadn't we seen it until recently? And it really is because we now have more powerful machines. So the processing power, the ability to scale, you heard the good discussion about scaling with multi-nodes, parallelization, all that is what makes a difference today. So now we can do that. But the key, as we're going to talk about, is when you start training machines, there is something about harnessing that power, but you actually have to think about it needs to be something that's going to be useful. You can't do it just for the heck of it or just do it because it's cool. There has to be something useful that comes out of it, right? So you have to be thinking about that. And when you combine machine and human intelligence, you have to think, what is the outcome? Start with an outcome in mind. Don't just do it because it's cool, but have an outcome in mind. Okay, so I'm just going to do real quick. We've heard all these definitions today, but I want to go over mine. I think if you think about big data, it's really about the collection, processing, and availability of huge volumes of streaming data in real time. It's not just big data because there's a lot of it. It's because it's coming at you fast, and it's a variety of data, right? So it's not just typical structured data. And the other thing about big data is that it has to be accurate. And in fact, that's why people like talking about big data, because it's more accurate than ever before, right? And it's applicable. You can do something about it, and there's actions. So the key for any business intelligence, machine learning, AI there has to be an important decision that can be made because of that. So that's the key, is we have to think about actionable and then authoritative, which means it's got a lot of different data sources that have come in, and so it's not just one data source. So the multiple data sources makes it authoritative. And then it has to be accessible. You have to be able to say, I've got all the data. And lastly, I couldn't think of a word that means security that starts with an A. I was trying to make them all A's, but I couldn't find it. So if somebody figures that out, please let me know so I can make it all A's, but I couldn't find it. I got one quick story to tell you about big data. So most of my experience in the past few years has been working and helping large manufacturing companies really try to get up to speed on the newer technologies from an IT perspective. And they're not always leading edge. In fact, sometimes they can be laggards in that. And so when this topic of IoT, Internet of Things comes up, most people think of the commercial application where the guy comes to your door, ding dong, I'm here to service your refrigerator. And they say, well, it's not really ready yet. Well, it will be, because they have the predictive analytics. They know all the numbers, they've crunched them, and they say, yes, in about 5 minutes, it's about to have a problem if I don't fix this. So that's, people think of IoT, they think of that. But when you think of these large manufacturing companies, it's much different than that, because they have to think about what are their products going to do. They're going to produce lots of data. And so I was talking to somebody fairly high up in a large manufacturing company, and I said, have you guys really started looking at IoT? And he said, we've had many discussions of IoT, but we don't know what to do with the data. It's like we know it's important, but you have to build an infrastructure to catch the data. And it's like, and then you have to say, well, not only do I want to catch the data, but I have to do something with it, right? So it's like, okay, we need help because we know and we hear about the buzz about big data, but we don't have a technology infrastructure to catch it. And you have to have an archival strategy. You have to have a way to process the data and find ways to keep the important data and archive the rest. And it's a big deal. So big data is not that simple. It sounds simple on the surface, but it's not. So then you think about the buzz was all about big data. And then as time progressed, you heard about machine learning. And what's machine learning and how that combines with AI. And that's when you have this technology that empowers connected machines, right? But not only connected, but they have the ability to learn. So you build a learning engine, as you've heard people talk about today, but it does still require human intervention. You have to have humans train the machine. And I was trying to explain to my wife yesterday about the presentation today, and she's not in technology, and so she said, I don't understand when you say training a machine, because I think she was thinking of like when you have a pet and you want it to roll over and you give it a treat when it rolls over the right way. And so I said, yeah, that's kind of it, right? So you train the machine, when it does the right thing, you key in, you did the right thing. And when the outcome is not what it should be, you say, that's not what it should be. So it is the same kind of deal, but it is obviously more complex than my pet, but same concept. And it does have these recursive experiments, because it's like it builds. So it's very much building as you learn. And then the last thing, like we talked about, is the IoT. And IoT is, to me, very key as part of this machine learning and AI, because the type of data you can get through IoT is very, I don't know what you call scientific or very exact. Like if you think about a sensing device, you talk about a preventative maintenance possibility. So for example, let's say you have a large pump, industrial pump, that's under the ground, right? Well, that's pumping oil through, for example. But what happens if it's starting to have an issue, right? So what happens typically is it goes out and they get a call. Hey, your pump just went out. You got to come out and service it. So in this case, you have the sensing device in there, and it's telling you it's reaching a threshold. You get an alert. You go out and you service it before it goes down, so they didn't have any downtime. So that's just one example. But there's many ways for the IoT devices to add value. But I think what's hard for many companies is to understand the true return on investment, the ROI of implementing IoT, right? Because they think about it and they go, yeah, I see that's valuable, but they're worried about how long it's going to take to implement. They're worried about, the infrastructure costs, the processing of the data. You have to have a way to process the data. So that's the key thing. And so what I've seen is that big data and machine learning have immense potential across a number of different industries. So manufacturing is one that I've had more experience in, but you've heard other examples throughout today, and you'll hear more examples later. So this is where I kind of connect the dots a little bit. And so why do we need data scientists? So I thought, hey, we should probably define what is data science. We're here at a data science conference. So I found this pretty cool definition and a really cool picture. I like the picture. It shows big data, It shows AI, shows machine learning, shows all the cool stuff. I like it. But I think data science is where you use scientific methods, math, statistics, and software tools to analyze and manipulate data. That's the basics, okay? And it's very different than a data analyst. Some of the companies I've worked at had data analysts, but no data scientists. The data analysts thought they were data scientists, but they weren't. And it was very difficult to explain the difference. But the other thing is that you connect information and data points to find connections that could be made useful. So typically, when you have an analyst in a company, they are in a functional area. I'm a financial analyst, or I'm a supply chain analyst, or I'm whatever industry, whatever organization you're in, you are an analyst for that. One of the biggest differences data science is more like, I'm not tied to any one organization or this one. I am looking at the data for the sake of the science of the data. Here it is, and you guys can go figure out how it applies, but I'm finding all the correlations, I'm finding all the nuggets of information, the patterns and things, and you've got to go figure it out. So they're more agnostic to the particular area, and that's one big difference. And they also are very good at moving organizations from just basic inquiries to insights. And they provide different perspectives on data they hadn't thought of before. And there's a lot of visualization tools out there, and a lot of BI platforms, a lot of analytics. But if you can't make a decision, if it's just a pretty graph or a pretty chart, but it doesn't lead you to a decision, what good is it? So I say it has to give you a new perspective, and it has to do that. If you look at, it's like the data science is in the middle of all this stuff, the hacking skills, the experience, the research, the math and statistics. So it's kind of right there in the intersection of all that. But Padmanand is going to speak in here a minute, but we were preparing for this presentation, and he came across something that I thought was extremely important. So I added it to my presentation. And basically, there is an aspect of data science that is missing today, and that is the ability to have communication skills. So if you can find nuggets of data, but you can't accurately communicate and convince people that they should do something about it, it may not go anywhere. So you have to be good in your communication skills as well as your technology. And that's a key takeaway. If any of you are really into data science and you're having problems with communication, take some courses, brush up on it, get good at it. You will excel, you'll be paid more money. All right, so anyway, data scientists. Now, I kind of led you down this path. So because of all what I've told you, data scientists will undoubtedly play a huge role in how businesses are run in the future. So that's why this role is extremely important. All right, so I've collected this over the years, my own experience. Sadu and I've worked together. You'll hear about him in a minute, his experience of what are some of these challenges. And we're going to talk more about this a little bit later on the panel. But I can tell you that the first one on the list, has anybody ever encountered this problem of working in a company and data's in silos? Why is it in silos? Anybody? Why?
Because you've got 80 copies of the database distributed across the nation.
So what happens is people get information out of a database and they go, oh, that's cool. And they get information out of another database and they put it together in Excel and they put it in a PowerPoint. And somebody goes, hey, that's pretty cool. But guess what? Nobody else has that data. It's not put together. And plus, which one is it that's the right one? Because I put my own spin on it, and he put his own spin on it, she put her own spin on it. So you have to get the data out of the silos into one place, right? That is not easy. I've got direct experience doing that. And here's what happened. I was at one company, 17 different ERP systems, but they want one BI system. I hadn't even heard of some of the ERP systems. They weren't even supported anymore. And the IT person was gone. So we were outsourcing this third-party company just to keep it up. Well, how do you go build a data interface to that system? Well, in some cases, we didn't. What we did is we just did what we called flat files. We had the people ask the question of their system the best they could and do it, export, and then we would feed that in. So usually if you have 20 data elements, they'll have 3 or 4. So it's very incomplete. So that is a very difficult one. And then integrating third-party data sets. So this is more and more popular. There's more and more data sets out there, but integrating the data sets with your own company's data is where you start really finding the aha moments. But like I mentioned earlier, you have to manage these quickly growing, very large data sets, and streaming data is one of the issues. We've run across a lot of new visualizations are very different. I would call them more interactive. So instead of a static pie chart, bar chart, column chart, you have these visuals that when you play them, they change over time. So they're showing you how something changes over time, and that's because they pulled in streaming data. Or maybe they pulled in Twitter data or Facebook data, whatever. And that really is what causes your visualizations to have to change and react. They can't be static. Now this one is something that was talked about earlier today, so I'm not going to go into a lot of detail, but you have to actually, when you build your system, you actually have to make sure that it scales over time. Like, you don't have to re-architect it. And there was a very good presentation this morning on when you start, think about that. Don't get rid of that thought. And then not only that, but one company I worked at, I inherited a system that was supposedly their analytics system. And so the first thing I did was ask it a question. And it sat there and it just spun, and I'm like, I thought I had done something wrong. And then finally it came up 2 minutes later with an answer, and I thought, well, that's odd. And so when I started asking people, what, do you use the system? They said, well, if you want to ask it something with a very narrow piece of the data, it works pretty well. But once you start asking a question that spans more data, it doesn't work. In fact, sometimes it just crashes. So I'm starting thinking, okay, so this was not built to scale, right? This does not have good performance. So we had to think, how are we going to get around this problem? And then also, with all the way that big data is related to machine learning, you have to build a platform to enable machine learning. And all of this together enables the data analytics. So analytics just doesn't pop out. There's a lot of work. One of the presentations earlier today said it took them 3 years to build the data and have the machine learn to where they can actually make accurate predictions. I thought that was pretty phenomenal. I think there's been stories of more than 3 years, but that was a good one I heard today. So long time. You can't do it quickly. So not only do we have technical challenges, but we have business issues. I have direct experience with this. Proper data governance. I tell you, there's a lot of data out there. And what's interesting, I talked about these functional groups within a company, and the issue is they have to own the data. They're the ones that actually put it into the system. They actually have to own it. So when we start doing data collection and we start doing BI systems and building it into machine learning, you have to make things match. So if there's 5 systems you're pulling data in, there's a data element that's common across 3 of them, but they have 3 different definitions of the data, it's not going to work. You've got to normalize that. You've got to say, when we talk about that element, it means the same in all systems. So there's data governance means you actually have to have regular meetings where you pull all the functional groups in that own the data, and the IT works with them and says, is this accurate? Yes or no? Well, what's wrong with it? Well, there's this, one of our sites doesn't have a good business process, so they just make up data when they enter that field. They don't know what to put in there. Well, then it's a retraining issue. Right? So now you've identified, you go to the root cause, you go back, you train them, and now they can do the system properly, and it gets the data better. So that's why it's not just technology, it's business process many times. The other thing too is this has really become more and more an issue, and that's securing the data. So you think about the danger of collecting all this data. So now it's no longer in silos, it's all in one spot. Yeah, cool, it's all in one spot. I only have to go to one place to get that data if I'm trying to hack in. So keeping the data secure is critical, and not only that, but data privacy. It's similar to security, but slightly different, because the privacy has really gotten big when you hear about the breaches. How many people have had to get a different credit card number because there was a breach? Yeah, I've had that happen, I would say 4 or 5 times in the past 2 or 3 years. It's like, what? Well, I mean, you can't protect your data? So you can see this is critical area. For other companies I've worked at, companies did government work, and intellectual property was extremely critical because you didn't want that knowledge making its way to a country that we're not in good standing with. And there's laws about protecting that data. And it's pretty onerous. And it makes it very difficult when it comes to having data warehouses and machine learning, because now you're, like I said, you're putting all the data in one place. It makes it easier for it to escape. So you have to really protect that IP. And then the last thing is there's a breadth of analytics. There was a presentation earlier where someone talked about the descriptive analytics, and then talked about first the descriptive, then the predictive, right? And then the perspective, and then the intelligent system. There was another one in there I have that was missing. It's called diagnostic analytics. Because when I think about it, it's descriptive is just saying what happened. Diagnostic is saying why something happened, right? Predictive is what will happen. Prescriptive is can I make something happen, right? And then intelligent system is where it all comes together, and that's the whole AI machine learning, and it's actually functioning and doing all that. But all of that doesn't work if you don't make sense of the data and you leverage value out of that data. I had a illustration one time. My VP was trying to make a point because they say, we just need the data. All we need is the data. And he said, no, that's not what no, that's all we need. So he said, okay, here's the server, and there's a disk in it. There's your data. And the guy goes, well, okay, so here's my point. It's not just the data, right? It's what you can take out of that data to make a good business decision. All right, so this is the third area, and this one I am definitely less of an expert on, so I'm not going to talk as much about it, but we have our friends that can maybe help a little bit. Now you talk about social and ethics issues. So we've talked about technical, we've talked about business, now it's the social and ethics. So the effects on human behavior and interaction. How is having AI changing our perspective? I love did anybody see the Roomba story? Did anybody hear the Roomba thing? Okay, I won't go into it, but it does have an impact on human behavior. You'll see it if you look at it after the conference. And then preventing manipulation of outcomes. So you really want to be channeled in the right way. I'm sure there's lots of movies on that. That one's from one you've probably seen, iRobot. The reduction of jobs. Some people I think are a little afraid. Well, if we automate some of the stuff I'm doing, I won't have a job. And then cybersecurity. So it's just not data security, but cybersecurity, very important. And then humans staying in control. This is the big one for me. So how do I ensure that the machines don't take us over? You hear all these, you see all the movies, you see all the stories. We got to stay in control. But there was another illustration I saw that maybe by the year 2025, the machines will be even with us. So what happens in 2026? They take over? I don't know. And then protecting against unintended consequences. So making sure that you train the machine properly. All right, so I love this illustration. Padmanand found this little graphic for me, and I love it. Basically says, IoT is the senses, big data is the fuel, and then artificial intelligence is the brain to realize the future of this connected world. So that's, if you think about it, so that's how you build it. All right, so then this is the last slide before we do our little panel. But basically, when you think about these outcomes for AI, there's an arrow, if you see it kind of going down, called continuous learning. So you start out with just what's happening now. And I talked about the descriptive analytics. Then what do I need to know? And it builds on that and what's recommended. And then now you start, number 4, you start the automation. We had an interesting issue. We talked about earlier, when you start your automation, what I've learned is that if you don't if you haven't worked something out manually yet to where you trust when it's done manually, and then you automate it, what you're doing is automating bad. You're just making what's happening bad faster. Think about it. If something doesn't work properly manually, and you can't model it manually, and then you automate it, it's gonna just blow up. So the automation, you have to be prepared for the automation, that it has to be accurate by the time you automate. And then what can I expect to happen? The prediction aspect of it. This is where it gets fun, right? But then what can I avoid? What's the prevention? And then situational awareness. And I was a great illustration about, identifying the wife. That was interesting because that's a situational awareness, right? And that's a very different than a lot of the outcomes for that. Okay, all right. So I've got a few questions. I'm just going to ask these guys to expound upon it. And like I said, take notes, and maybe it'll trigger a question. But to make it flow better, when we get done with our question and answer, then we'll ask you to ask your questions, and we can answer it the best we can. So let's go for it. All right, so Padmanand, you talked about Microsoft. But by the way, he worked at smaller companies too. How many have heard of DSIQ? Okay, he worked there too. All right, so cool. So you worked at both those companies, but what did you see that was maybe similar between the two companies when it comes to how they handle big data, and maybe what was different?
Okay, great question. So the first thing that comes to mind is, regardless about the size of the organization, you got to think about the purpose. What's the strategic objective of why you want to invest in big data, AI, machine learning, all of this stuff. And the point is that, unless you really have a good idea where you're going, you may not end up in the right place. And people tell me, Padmanand, it's hard to get started with big data. And I say yes, but sometimes it's hard to stop with big data. And so if you're a small company, the margin of error is more, because you have fewer resources, time, and so if you guess wrong, it's going to hurt you. There's three things that come to mind in this context, and we've touched on some of that this morning already. But first, just to reiterate, in my experience, it's always going to take you more time to operationalize and maintain the big data. It's going to take you more resources and more time than you had anticipated. And what that means is you've got to sort of think about who you're going to hire, how you're going to train them, how you're actually going to keep them from going over to your competition or to some of the bigger companies who are trying to get to the same very scarce resources. So as a small company, you have that challenge. You also have the challenge that if you haven't architected your data pipelines appropriately, the volume of data that's going to come in production may be much more than, you may have architected for this much, and then all of a sudden you have this much coming in production. You've got to go back and retool, and that's another challenge. And the third one comes to data governance. People think about, I got to have retention policies for my data, but then, when you got IoT, you got transient data. Are you going to capture every data point? Probably not. So, how are you going to think about policies around data retention, and how are you going to have procedures in place, as well as the tools that you're going to be able to let up and down your organization communicate, up, down, sideways, whatever you need to know, that these are the policies, because otherwise you're going to just burn a lot of Azure or AWS cycles just storing and processing data that you may not need. So those are three challenges that I can think of. And again, it goes back to the purpose before jumping in, because I've seen companies just get in and sometimes have to stop midway because they just couldn't afford it.
In fact, there's a statistic I ran across in my research that today, two different surveys, one said 75%, one said 80% of all IoT projects fail. That's what's happening right now. And that's a lot of the issues that I talked about earlier and Padmanand just now talked about is part of that problem. Is that you have to prepare, you have to have a plan. You can't just say, hey, let's go do the big data. Yes?
So you come with experience in implementing these types of projects, going to customers, trying to discern how to navigate the newness of IoT.
Right.
Can any of you all explain for us how you're seeing that dynamic
Right.
projects, and what should we expect? Because the dynamics are very different, again, than the traditional hardware or software
Right.
implementation and procedure. So I see a lot of confusion between.
I'll repeat it. You take it. Okay. All right, I'm going to try to repeat that, but obviously I didn't memorize it. So the traditional model of just selecting software and implementing it is the way it used to be, but it's not that simple when you have machine learning and AI. So how do you get started? How do you handle it? Because that whole dynamic has changed. I've got a little bit I can say, then I'd like these guys to chime in. But what I think you have to do is you have to realize that there's people out there that have done this. So you have to leverage that. I would not recommend just with your own IT staff, just do it. I don't think it works. Now you may have a good IT staff that you can have augmented with consultants to come in, or maybe you just rely on consultants, but I think you have to find people that know what to do, and they have to help in that. Otherwise, you're going to do it wrong. You're going to be one of the 80% that failed. So I think you have to do that, and I'll let these guys give more real-world experience on that.
Yeah, that's true. Like there are not many success stories, but there are good references you can use to start with, and using some of the experts who have already done it and take their help, and then start small and then grow on that. That's the typical way to address these issues.
Yeah, I would just add, again, it goes back to purpose. We talked about, what's your primary reason? Are you first trying to just get into descriptive analytics? Are you trying to then get into more predictive? You sort what you want to do, because even if you brought a consultant, you need to have that kind of, clarity of thinking before you jump into a project. And the guidance would be obviously start small. It is a good question. I don't know if there's any magic bullet on that, quite honestly. I think you have to sort of really figure out what you want to do, even if it is just maybe basically you're just going to say, I'm going to invest in this so I can discover what's out there. That's okay, and you can put a timeline and budget around it. But there is no, at least in my experience, a way to say, oh, here's the way that I know precisely what I'm going to do, because things are changing so much. There's so many tools out there, even in the open source community. We saw this morning, right, this whole chart of companies and tools out there. It's kind of a myriad of things to sort yourself through. So I would say just caution advised, ask good questions, and go from there.
All right, thank you guys. All right, so number 2, we're going to really think about, how many have heard of data lakes? I'm sure a lot of you have heard of data lakes. How many have heard of data warehouses? Data warehouses, okay, cool. So, Sadu, what's the difference between a data lake and data warehouse, and what are some of the benefits of having a data lake?
So let's first define what's not data lake. So, right, data lake is not a dumping ground where you can bring all your files and put it into one place. So data lake is well architected, well managed with all governance, where you can bring all your data, whether it is structured data, unstructured data, semi-structured data, into one place, like common repository, and you store in the original native raw format. And in the well architected data lake, in addition to that raw the data, you will also have some processed data, massaged data, and the integrated data. So what that gives you is the ability to eliminate all these data silos, and in one place for your analyst, data scientist, you can get the data you need for your purpose, all in the detailed, the raw format, in some cases maybe integrated processed data. So when you use this, the detailed, the raw data in one place, and you use, for example, machine learning, when you use this detailed data from all your data sources, internal or external, you have access to more data and all kinds of data. So you can train the model, and you can build models where you can accurately predict. You get a better accuracy when you use all kinds of data. In the second, these data lakes, not only you have the raw data, you don't have, unlike your traditional data warehouse or the data marts, you don't have to define your schema upfront, and you don't have to transfer your data through your ETL to transform the data into the format you need and load the data before you have access to the data. So there is a concept of schema on read. So you have the data in the raw format. You don't need to do any conversion. You apply the schema at the time of data access or analytics. So that means I can bring the data into my data lake, and analyst will have access to the data immediately, right? So you avoid upfront time defining your schema, transforming the schema, loading the schema, etc. So that shortens your cycle to have the analytics done when the data is available or when you bring the data. That's a huge advantage. And in addition to this data, you also have the metadata, the defining what kind of data you have. So data cataloging, data definition, and the data, the availability, the quality of the data. So that's where when I said it's not just about the data. When you architect correctly, you will have the data, metadata defining the data, and you have governance principles that are defined, who has access to what data. So when you combine those, you will be able to make faster and smarter decision.
Pretty cool.
And in addition, the other, I think the major benefits of data lake is you have access to variety of tools. It's not limited to one, say, SQL or so. Depending on your needs, depending on your expertise, you can use different tools, and also you can use in combination of tools. So that gives you more flexibility.
Thanks. And just a reminder, I've included there in this presentation. There's a bunch of slides after this that we're not going to go over. I've gone through the different areas and said what are some of the key technologies today in these different areas. So all the ones that they're discussing will be in that summary. So I'll just encourage you to refer to that. But related to this, I have another question for Padmanand, and I'd like to hear your perspectives on your approaches, the differences of approaching between data warehouse and data lake.
Sure. We also had a question, but let me answer the Jerry's question. Maybe we open it up back up.
Oh, sorry.
Yeah, because I just want to kind of keep the context here. So, if you step back all the way, right, and think about how do we as humans make sense of all of the data that's coming at us, there's fundamentally two approaches. There's a top-down sort of inductive reasoning that we have, right, and then there's a bottoms-up deductive reasoning. And data warehouses have come from the world typically of top-down reasoning. You start with a theory, you have a hypothesis around what could happen. You look at observations that help you confirm or refute those hypotheses, and you kind of go from there. And that's useful for in the realm of descriptive analytics that tells you this is what happened, or diagnostics that tells you why something happened. But if you go to the idea of deductive reasoning, you actually sort of invert things. You start with an observation, actually, and then you look for patterns, and then you try to form some kind of hypotheses and theory to explain those patterns. And data lake helps in that kind of analysis, more of the predictive analytics or the prescriptive, like, is so-and-so likely to be a good customer, and then once so-and-so is a good customer, what can I do as a next best action to make that a loyal customer and keep him or her, right? So data lake helps in those kind of decision making, where you're getting data as fast as you can, and you're just putting it away and then coming back and taking a look at it together. The other point I want to make is, don't think of these as either or. It's a continuum. And again, it goes back to what I've been starting from the beginning as well, is it goes back to your purpose. Where do you want to start and where do you end up with? Do you want to start by actually just doing discovery of data and then looking for the pattern. So you might want to start on that side of the spectrum. Or if you're just looking for basic diagnostics, you might want to start at the other end of the spectrum. But just be aware that these are not exclusive.
Right. In fact, there's a couple of things I've come across that are very useful. The ones that are called the BI maturity curve. Has anybody seen that? There's different versions of it. Gartner's got one. Others have it. Okay. Those are very good to go down. All right. All right. So Sadu, we're going to go to the next question. Actually, I may skip a little bit because
Can we take a question from the audience?
oh, that's a good point. Since we kind of are taking longer, let's do a question from the audience. Yes.
Okay. Actually, I think she was here first.
Yeah. Okay. Go ahead.
Okay.
Which one?
Okay, so you talked about data lake, right? That we have structured and unstructured data. And you said that we have metadata about it. So, okay, I get it that when we have a structured data, we can have a metadata about it. But how about semi-structured and unstructured data? How can you have a metadata about it? Because it may be the case that when you have the data, you might be having missing values. Values might not be present. It's streaming, we have no structure present. How can we have metadata about it?
Okay, great question. Again, when you talk about the metadata, there are different kinds of metadata. You have, like in very high level, you have the business metadata, and then the technical metadata, and the operational metadata. Even when you have a semi-structured or unstructured data, there are some kind of information is available that you can capture. For example, just the general definition of those kind of the data sources, or where the data comes from. And even when you talk about, say, semi-structured, say JSON or XML, there is some inherent structure is already included. It may not be your familiar relational structure where you have well-defined rows and columns. Even when you talk about semi-structured, unstructured, there's some definition defined. And not only we capture, again, probably it's not just the schema. As I said, what's the source? Who is the owner of that source? And what was the recency of capturing that data? Because when you are presenting, you will have to say whether this data is 1 week old or whether it's as of today. So you can define, and all these big data tools will be able to capture, process, and analyze even in the different format. You can analyze the JSON in its native format, XML in a native format, or text analytics, or even if it's compressed. So that's where we say when you can do the analysis on the raw data, you don't have to convert that into your familiar rows and columns schemas. Did that answer your question? Thanks.
Okay, we've got another question over here.
As you mentioned that 70 to 80% data science projects are failing, and being from this industry like the data science, is there any research which you try to dig deeper? What are the top reason or the failure, and why the ratio is not increasing? It's still the same, because like 4 or 5 years back it was still 80%. Now it's still around 80%. Why we are not learning?
I have 5 different slides at the back. One about the main technologies. They talk about what you have to do. Oh, they talk about what you have to do. So I look in there for that, but that's not what I was looking for. Let me go back. I thought I had one slide on this, on the AI. Yeah, I don't know. I don't have the slide on that one. I thought I had one. There's probably something I deleted. But
yeah, I
take
can
it.
Answer based on what I have seen in client places. So there are multiple reasons, right? One, probably not having the expertise, or the second, probably you don't have the right use case that supports your main business goals. And so that means you may not have the upper management support. and it could be related to technology or architecture, right? And all these tools and are still evolving, right? So you may not have the defined the methodology, the architecture to follow in, for example, the traditional data warehousing or business intelligence. We used to have the similar failure rate if you go back to the 90s. Now, as you and you have more experience, more well-defined the methodology, the architecture that you can use as your starting point, those you can now architect and design better solutions and more quickly, where with all these new tools and technologies, we are not there yet. Right, so the lot of cases, I think it's because, and also the very common failure what I see is not setting the right expectation. So when you say failure, if it is not within the time, within the budget, or not meeting the initially defined goals, that's considered as a failure. Right. So that may be because you don't have the expertise to define upfront your expectation correctly.
So most of this implementation has been suppose there is a small startup or even there is a medium-sized company. Whenever they are going for implementation of big data technology, they don't do it by themselves, like 90% of the time. Right. Most of the time they will hire external consultancy. So first point you mentioned, maybe we don't have the expert knowledge. So they are trying to bring that expert knowledge by trying to hire a consultant. So I believe that consulting should be able to provide a roadmap that if a client is setting his expectation too high, then maybe they should, okay, this is what is possible, right? So is that not happening, that there is a good communication between the consultancy they are bringing in and the client? Where is mismatch?
I think again there are lot many success stories also. So I think.
Yeah, I think there's different measures of success. One was the budget, one was defining the problem, and one is being able to actually then verify that you solved the problem. I heard a quote out of a small company called Microsoft, and it says, think big, but start small and go fast. So in other words, think big, plan big, but don't start big. You take one little slice and you say, look, we solved that problem. Cool, let's do another one. Oh, we solved another one. Oh, the third one we didn't solve. Fine, put it aside. So you have to build on it. So you can't just try to boil the ocean. That's usually number one. You try to make it too big and it fails. That's number one.
Okay, then we have one more question, and then after that, keep in mind that at the networking event, you can ask more questions to get on the panel.
Yeah, this is just for the panel in general. In the context of the marketing application of big data, deep learning, and AI, it seems the technology has the faculty to perpetuate and potentially even exacerbate personal biases. Just wondering kind of how the experts would consider an approach to combating that type of issue.
Padmanand, you want to take that?
Yeah. So this is a complex topic that can easily take up an hour or more. Yeah, but the net is this, that the danger is that we as humans have biases that we may inadvertently program into the machine to perpetuate those biases. And I think Jerry talked about it, is that if you automate something, and now you have the danger of amplifying it. So there's the quick version of that is there's an organization called AI.now, as well as Partnership on AI. The Partnership on AI is more like self-policing. It's a bunch of all the major companies: Amazon, Microsoft, IBM, DeepMind from Google, Mustafa Suleyman on there. They're all part of these thought leaders thinking very hard about this intersection between legal, social, and technological issues around bias as one of the issues. But I can talk offline since we're out of time here.